Here we'll take our first look at quadratic functions, or parabolas. Parabolas, quadratic functions, are U-shaped functions created from a second-degree equation. A second-degree equation is one in which the highest exponent, or the highest power, is a 2. Here are 4 examples of quadratic functions. They're all given in function notation, but of course you can read f of x as a y. So we could read f of x is equal to x squared as y is equal to x squared. We use this notation interchangeably. Remember, the function notation is just a convenient way to indicate which values of x we are substituting into the equation in order to solve for the value of that function, the value of that equation, at the given value of x. In any case, these equations look quite different, but what they each have in common is the highest power that x is raised to is a 2. In some instances, this is quite easy to see, as in the first two, which are written in standard form. And it's not quite as straightforward in these other 2 examples, but if you expand the equation that's given in factored form, this third one, you'll find that the highest power that x is raised to is a 2. Likewise, when the equation is given in vertex form, when we expand x plus 2 raised to the power of 2, we find the same thing. Parabolas are symmetric, so they're mirrored around a vertical plane. This vertical plane cuts through the maximum or minimum value of the equation. This vertical plane is called the axis of symmetry. The 3 key points of a parabola are the vertex, the x-intercepts, also called the roots or the solutions, and the y-intercept. The vertex is the point that is the maximum or the minimum value. If the parabola opens upwards, the vertex is a minimum value, but if the parabola opens downwards, it would be a maximum value. It's the center of the parabola in the x direction, which means that half of the parabola is found on the left of the vertex and the other half on the right. The vertex is on the axis of symmetry, so the left-hand side of the parabola is identical to the right-hand side. The x-intercepts are where the parabola crosses the x-axis. We find the x-intercepts by setting y equal to 0. In this example, we have 2 x-intercepts. A parabola can have up to 2 of these intercepts. If the parabola is sitting directly on the x-axis, we'll still say that it has 2 solutions, but we'll only be able to see one of them. The third possibility is that the parabola doesn't cross the x-axis at all. Every parabola has a y-intercept, and this is where the parabola crosses the y-axis. We find this value by setting x equal to 0. As we saw on a previous slide, we can write the equations for parabolas in several different forms. Each form is useful in its own way. They highlight different key parts of the parabola. Factored form can be written like this: f of x is equal to a times x minus s times x minus r. Here, s and r are the roots or the solutions to the parabola. The factored form, therefore, highlights the x-intercepts. The standard form of a parabola can be written as f of x is equal to ax squared plus bx plus c. This is a very common way to write a parabola, and it highlights the y-intercept. This means that the y-intercept will be the easiest point to find if the parabola is written in standard form. Vertex form, fairly self-explanatory. We write f of x is equal to a times x minus h all squared plus k. The easiest point to find here will be the vertex. We're going to spend our time looking at standard form as well as vertex form. One thing I'd like to point out right away is that, of course, x is always raised to the power of 2. Sometimes this is obvious. Sometimes we need to expand, multiply the binomials before we can see this. Start. And the other thing that each equation has in common is the value for a. A plays the same role in each form of this equation. The value of a tells us whether the parabola opens upwards, This happens when a is a positive value, or if it opens downwards, which happens when a is a negative value. It also tells us how narrow or how wide the arms of the parabola are. Regardless of which form of the parabola we're looking at, we will find the vertex, the x-intercepts, and the y-intercepts, and also have a look at the coefficient for a to immediately tell us whether the parabola opens upwards or downwards and how wide we can expect the arms to be.